In 2004, astronomers ran their calculations 3 times, then a 4th. Then they called their colleagues and said words that hadn't been spoken in the history of modern science. This asteroid might actually hit us. Not someday, not in theory, in exactly 25 years. The probability was 2.7%, and they named it Apophis, after the ancient Egyptian god of chaos and destruction. That name wasn't chosen lightly. Here's the detail almost nobody is talking about right now. There's something quietly broken about how we're watching this thing approach. Something that should be front-page news every week. Something that changes what we actually know and don't know about what happens when Apophis arrives in April 2029. Picture the night sky 3 years from now, April 13th, 2029. You step outside, you look up, and there it is, a point of light moving slowly across the sky, visible to the naked eye, crossing the heavens like a slow, silent intruder. That's Apophis. A 375-meter rock, wider than the Eiffel Tower, is tall, passing closer to Earth than the satellites providing your GPS, your weather forecasts, your bank transactions. Not a simulation, not a drill, actually happening, right above your head. Your neighbors would be watching. News crews would be filming it live. Social media would stop entirely. The entire planet would look up at the same moment, at a rock that once had a real probability of killing every person looking at it. But here's what the headlines keep leaving out. In December 2020, the most powerful planetary radar telescope ever built collapsed. The 900-ton receiver at the Arecibo Observatory in Puerto Rico broke free of its cables and dropped 140 meters into the dish below. Nobody was hurt, but the instrument was irreplaceable, and it's gone. NASA's primary backup, the Goldstone antenna in California, is currently offline for major repairs. We are 3 years from the closest approach of a large asteroid in all of recorded human history, and our best radar eyes are dark. To understand why this matters, you need to go back to that original discovery. 2 astronomers at Kitt Peak Observatory in Arizona spotted a faint moving smudge in June 2004. They tracked it for 2 days before weather shut them down. 6 months later, a team in Australia picked it up again, and when the numbers came back, that 2.7% impact probability briefly appeared. For context, the odds of hitting a single number on a roulette wheel are about 2.7%. Apophis had nearly the same chance of ending civilization as a casino chip has of turning a profit. Emergency calls were made. Scientists pulled all-nighters. Governments quietly opened conversations about planetary defense for the first time in decades. Within weeks, additional observations refined the orbit. The number dropped, then dropped again. By 2021, after extensive radar tracking from both Arecibo and Goldstone, NASA officially removed Apophis from its planetary risk table. No danger of impact for at least a century. The world exhaled. The headlines moved on. And that's where most people stopped watching. That was a mistake. Here's what the 2029 encounter actually looks like on paper. Apophis will pass approximately 32,000 kilometers from Earth's surface. Our geosynchronous satellites, the backbone of modern telecommunications, navigation, weather monitoring, and military early warning, orbit at roughly 36,000 kilometers. Apophis passes beneath them, a rock larger than a skyscraper, moving at 30 kilometers per second, threading a path through the belt where we've placed everything civilization depends on. Now here's where it gets stranger. Scientists are confident about where Apophis is going in 2029. The uncertainty in the approach distance has been refined to just a few kilometers, extraordinary precision. But that confidence depends on something called the Yarkovsky effect. When sunlight hits an asteroid, the heat it absorbs doesn't radiate evenly. The uneven thermal emission creates a tiny but real push on the trajectory, enough over decades to shift where it actually arrives. Including the Yarkovsky effect in orbital models shifts the predicted 2029 position by roughly 300 kilometers compared to gravity-only calculations. Quantifying it precisely requires detailed knowledge of the rock's shape, mass, and spin axis. And the primary instrument for gathering that data, Arecibo, no longer exists. Remember what I said about the thing nobody's discussing? This is the second half of it. Without Arecibo, and with Goldstone unavailable, pre-flyby characterization is being done by optical telescopes and 2 spacecraft missions now racing toward Apophis. NASA's OSIRIS-APEX, the repurposed OSIRIS-REx probe that returns samples from asteroid Bennu, is already en route. ESA and JAXA signed a joint agreement in May 2026 for the Ramses mission, which will reach Apophis before the flyby and monitor it in real time. These missions will tell us things radar never could, but they're operating in territory that's harder and slower than the radar observations we built our safety confidence on. And here's what nobody can tell you yet. After the 2029 flyby, Apophis's orbit changes. Earth's gravity will reshape its path in ways that can't be precisely calculated until after the encounter itself. The post-2029 trajectory depends entirely on how close the approach is, how Earth's tidal forces alter the asteroid's spin and internal structure, and new Yarkovsky parameters generated by those physical changes. Scientists will do that math in 2029. What the asteroid does in 2036 and beyond, those answers don't exist yet, which means we need the best possible measurements during the encounter, from every instrument we have left. Think about what you're depending on right now. Every satellite in geosynchronous orbit is doing something. GPS routing your commute, systems connecting emergency services, infrastructure running global communications and finance. When Apophis passes through that zone, scientists are clear, no individual satellite is threatened. But the point isn't a collision. The point is that we are observing the closest known approach of a large asteroid in the entire history of human civilization, using fewer ground-based instruments than at any moment in the past 20 years. Here's what science has confirmed, clearly and without ambiguity. Apophis will not hit Earth on April 13, 2029. It will not endanger any satellite. It will pass by safely, become visible to the naked eye across Europe, Africa, and Asia, and continue on its way. That is the scientific consensus, and it is solid. No single researcher working on this believes otherwise. The math is good, but something unprecedented happens that night regardless. Earth's gravity will stretch and compress Apophis as it flies past, potentially triggering quakes across its surface, permanently changing its rotation. We will watch in real time a planetary body being physically remade by our own gravity. It has never happened like this before. It will never happen like this again in our lifetimes. The God of chaos is coming. We know it. We're watching it. We named it accurately. So here's what I want to know. April 13th, 2029, are you going outside to watch it? And does it concern you that the planetary radar we built our confidence on is no longer there? Because this is the kind of event that deserves every eye, every instrument, and every ounce of attention we can give it.